What if I told you Earth has lakes you can't see, can't touch, and can't even photograph directly? Yet satellites can still watch them fill and drain from orbit? Right now, as you watch this, there are 400 plus known subglacial lakes under Antarctica, liquid water trapped under kilometers of ice in total darkness. And some of them can make the ice above rise and fall by meters. Stay with me, because the biggest secret isn't that these lakes exist. It's what happens when they move. This should be impossible. Antarctica is cold enough to snap eyelashes, yet it hides water that isn't frozen. But the mind-bending facts are real. Researchers have cataloged 400 plus subglacial lakes, forming a hidden water network. Some lakes actually drain and refill, shifting enough mass to deform the ice surface above them, something satellites can measure. And one subglacial environment that was sampled showed evidence of microbial ecosystems living without sunlight, powered by chemistry instead. So here's the question scientists are genuinely wrestling with. Are these lakes just ancient time capsules? Or are they part of a plumbing system that can change how fast ice slides into the ocean? Let's start with the normal science. Why liquid water under ice is even possible. A subglacial lake stays liquid because of three forces working together. First, pressure. Under kilometers of ice, melting behavior changes, and the base can hover near melting. Second, geothermal heat. Earth leaks heat upward everywhere, including Antarctica. Third, insulation. Ice is a blanket. It traps heat and keeps the base from losing energy to the surface. This is where things get strange, because subglacial lakes aren't just water sitting there. They're part of the ice sheet's mechanical system. Water at the base can reduce friction, like turning rough sandpaper into a slip and slide. That can help ice streams move faster. And speed matters because an ice sheet doesn't have to melt completely to raise sea level. It only has to flow into the ocean faster. Now you might be thinking, how do we even know the lakes are there? That's the detective part. We use radar sounding. Radio waves travel through ice, and liquid water often gives a bright, mirror-like return. We also use satellites. If a lake fills or drains, the ice surface above can rise or sink. Missions that precisely track ice elevation and mass change allow scientists to infer hidden water movement without seeing the water directly. So in a simple world, you'd expect, find a lake, map it. It sits there. But Antarctica is not a simple world. Subscribe if you like science that feels like solving a mystery with real evidence, because what I'm about to reveal is the three-step method scientists use to unlock these hidden lakes. How we find them, how we watch them move, and why one drainage event can matter more than 100 pretty maps. Stay with me here. Let's tell the story chronologically, like detectives. First came radar surveys revealing suspiciously smooth, bright reflections under the ice. Liquid water signatures. One hidden lake became famous. Lake Vostok, buried under roughly 4 kilometers of ice and about 250 kilometers long. Basically an inland sea under a frozen continent. Then the satellite era changed everything. Scientists showed that some subglacial lakes are active. They drain and refill, and the surface above them moves in response. That was the big twist. Not just lakes exist, but lakes behave. Then came the biology cliffhanger. Researchers accessed the Lake Willen's subglacial environment and reported evidence consistent with microbial life, an ecosystem running on chemistry, not sunlight. You might be thinking, so Antarctica has alien-like habitats on Earth? Exactly. And by the 2026 era, with longer satellite time series and more radar coverage, the question shifts from where are the lakes to which lakes connect, which drain, and what does that do to ice flow? Here's where it gets crazy. The secrets of Earth's hidden lakes come down to three big ideas. Secret number 3. They're not isolated puddles, they're networks. Some lakes link through channels under the ice. It's like plumbing in a building you can't enter. You never see the pipes, but you can prove they exist because different areas rise and sink in patterns that only water flow can explain. Secret number 2, they can switch from quiet to violent. A drainage event can send a pulse of water downstream, changing pressure at the base. That pressure change can temporarily alter how the ice slides, like lubricating a stuck drawer and watching it suddenly move. Scientists debate how often this meaningfully speeds ice streams, but the mechanism is real and measurable. Secret number one, these lakes are planetary test beds. When you find microbial ecosystems in dark, pressurized, isolated water, you're not just learning about Antarctica, you're learning what habitable means without sunlight. That feeds directly into how we think about icy ocean worlds like Europa and Enceladus. So the satisfying answer is, hidden lakes exist because physics allows liquid water under ice, and we can detect them with radar plus satellites. But it raises a sharper question. If water can reorganize under the ice, how predictable is ice sheet behavior as climate forcing changes the system? Just when you think you understand, here's the twist. Not every lake signal is guaranteed to be a big pool of clean water. Radar is powerful, but it's not a magic camera. Bright reflections can also come from wet sediments or salty brines. Some lakes might be slushy, layered, or chemically extreme. That changes everything: how water flows, how ice responds, and whether biology can thrive. And now we hit a real controversy. How do you confirm what's down there? Drilling gives ground truth, but it's hard, expensive, and raises contamination concerns. Remote sensing is safer and global, but it can leave ambiguity, especially when you're interpreting signals through kilometers of ice. So the mystery in the 2026 era isn't, do hidden lakes exist? It's, how many are active, how connected are they, and which ones matter most for ice stability and sea level? I genuinely want to know what you think is the wildest part of Earth's hidden lakes. A. The lakes that drain and refill like a buried plumbing system. B. Microbial life in total darkness. C. The sea level connection. Water changing how ice slides. Comment A, B, or C. I read the comments and I'll pin the best explanation, because this affects all of us. Subglacial water sits at the intersection of climate, geology, biology, and space technology. If we want better sea level projections, we need to understand not only melting at the edges, but friction at the base, and water controls that friction. The more we learn about hidden lakes and subglacial channels, the better we can model how fast ice could move into the ocean. And there's a second payoff. Earth becomes a training ground for space exploration. The same toolkit, radar sounding, remote sensing, sterile sampling protocols, is exactly what we'll need for icy moons. Future directions are clear: longer satellite time series, better radar coverage, improved models of basal water pressure, and cleaner sampling methods that reduce contamination risk. The hopeful part is, we're not blind anymore. We can watch the ice surface breathe, track changes year after year, and test models against reality. Every new season of data reduces the mystery and increases predictability. But this isn't the only hidden water story on Earth. Next, we'll break down how radar can see through ice like X-ray vision, why icy moons might be the best place to search for life, and the strangest microbes living in places that should be impossible. Subscribe so you don't miss it. Thanks for watching. The most alien environments might not be light years away. They might be under our feet, sealed under ice, waiting for us to understand the rules. Stay curious, and see you in the next one.